I'm delighted to welcome you to our first webinar of the 2026 webinar series. My name is Satwinder Paul, and I'm the Associate Teaching Professor in Water and Wastewater Technology program. Alongside a team of experts, I oversee the Online Help Center for BC Small Water System. Before we begin, I would like to acknowledge that Thompson Rivers University campuses are located on the traditional lands of Tecumlip Swepmec and the Tiksalek within the Swepmec Ulu, the traditional and unceded territory of the Swepmec people. Thompson River University and its partners host an annual free webinar series and courses designed to provide technical information, resources, and tools to all small water systems owners and operators, including Indigenous small water systems. These webinars, courses, and the website cover topics such as treatment, regulation, operations, maintenance, and water quality monitoring. The Online Help Center is committed to assisting small water systems across BC in implementing the multi-barrier approach to drinking water, uh, ensuring safe, potable drinking water for their communities in compliance with government regulation. Our free webinars are scheduled every 2 months. If you are EOCP certified operator, each webinar will count as zero point 0.1 CEU towards your certification. Upon completion, participant will receive a certificate which can be submitted to EOCP for CEUs. Today's webinar will feature a 1 hour presentation followed by a 30-minute question and answer period. If any question arises during the presentation, please note them in the chat section and we will address them after the presentation. Our topic today is knowing your well and tracking its performance. The webinar will focus on topics such as the construction of a well from the well record, the factors that govern well yield and ongoing well performance, what to monitor to track performance over time, and strategies to address declining performance as well ages. It's my pleasure to welcome our presenter, the learned Mike Way. He's a highly trusted groundwater professional who has over 40 years effectively collaborated with various government agencies, regional health authorities, and industry on groundwater resource development and management project. Mike is also highly sought after instructor in hydrology and has developed and delivered numerous workshops for water operators. Welcome, Mike, and we're so pleased to have you. So I'm going to turn this over to you now.
Thank you so much, Satwinder. I hope everybody can hear me clearly and are able to see the slides. Thank you for inviting me to the first webinar of the 2026 season. I'm hoping to present to you information about how to get to know your well better and tracking its performance. As Satwinder said, this webinar is 1 hour in presentation, followed by half an hour for questions. The continuing education units is 0.1 CEUs for the Environmental Operator Certificate Program, and 1 hour for the people in engineers and geoscientists of BC. I also want to recognize the Indigenous territory and peoples where I live and work in southern Vancouver Island, in the Coast Salish territory of the West Saanich people. Before I begin the presentation, I would like to take an informal poll. I'm going to put the questions up here quickly, and then Natasha Scott will manage the poll of the people attending, and we'll see what the results are. So the questions are, does your water supply system rely on a well? What percentage of your time as a water operator is spent dealing with your well? Do you monitor the water level in your well, the quantities pumped, the specific capacity of your well? Do you look at the monitoring results to understand your well's performance over time? And so with that, I'm going to hand it over briefly to Natasha to run the poll questions with you. Natasha?
Mike, we finished the polls. So you
Okay,
can share
is it
them.
possible for, is it possible for you to share the results?
Sure. You want me to go one by one?
Sure.
Okay, so does your water supply system rely on a well? 60% say yes, 20% say no, and 20% say they don't have a well.
Okay.
Just let me know if you want me to keep
Please
reading.
keep going, Natasha.
Okay. What percent of your time as a water operator spent dealing with your well? 12% hardly ever, less than 10%, 30% of people, less than 25%, but more than 10%, 18% of people, more than 25%, 5% of people, and 35% say they don't have a well.
Okay.
Next question, have you had training in groundwater and wells? 59% say yes, 41% say no.
Okay.
Do you monitor the water level in your well? 42% say yes, 28% say no, 30% don't have a well.
Okay.
Do you monitor the quantity pumped? 53% say yes, 17% say no, 30% don't have a well.
Okay.
You monitor the specific capacity of your well. 29% say yes, 40% say no, and 31% don't have a well. And do you look at the monitoring results to understand your well's performance over time? 41% say yes, 28% say no, and 31% don't have a well.
Okay. Thank you very much, Natasha. And I guess I'm going to keep going on the presentation. It's actually encouraging to hear that a large percentage of you do monitor and do look at the data, but there's also a percentage who do not collect data or do not look at the data once they're collected. This presentation I'm doing, I'm going to make the assumption that not everybody knows are knowledgeable about wells and groundwater. And I hope for those of you that are very experienced, you'll still get something out of this presentation. But let's go on and start. So the agenda, the presentation is of 4 parts with questions later. The first is knowing your well from the well record. Second is understanding well performance and yield. The third is understanding the factors that govern well yield and well performance. And the fourth, what to measure to track well performance. So for the first item, we're going to look at some learning objectives. We're going to look at some basic components of a well. We're going to learn, or at least understand, how to search for a record of a specific well in the province's GWells database. We'll look at the importance of interpreting the well's construction and lithology from the record. And personally, diagramming the well, I find, is very helpful. And finally, identifying the source aquifer from the well record. So this may be a situation that some of you may have encountered. I just started working for a water supply system. I don't know much about the well because no one kept any records. And so let's start off with just the basics of what a well is and some of the works and components of a well and what their purposes are. So let's start off with the basic well components for a well drilled into an unconsolidated or sand and gravel aquifer. And let's start at the bottom here. I hope you can see my mouse with the well screen. The well screen is really a stainless steel intake that has slot openings that allow water to enter the well, but not sediments. Above the well screen is the production casing. Production casing for water supply wells are typically made of steel, and they vary anywhere from 6-inch diameter to larger, depending on the volume of water that needs to be pumped out. The production casing keeps the hole open and conveys water from the well screen up to the top of the land surface. At the upper portion of the production casing, between the ground and the casing, the driller has installed usually a surface seal. A surface seal comprises bentonite clay, usually around 1 or 2 inches thick, all the way around the production casing in the upper portion of the well here. Typically, the length of the surface seal is 15 to over 20 feet long, and the purpose of the surface seal is to prevent any contaminated runoff from seeping down the outside of the production casing, dribbling down into the bottom of the well, and making it into the inside of your well as part of your water supply. The production casing typically sticks up above ground. The minimum stick up is 12 inches. Many drillers are leaving a stick up of 24 to 36 inches. And the reason for the well casing to stick up above ground is to prevent any water from overtopping the wellhead and entering the well to contaminate the supply. At the top of the well is a well cap, and the well cap prevents stuff, crap, junk from falling into the well. The picture on the lower left here shows a well driller and his assistant or helper lowering down 2 sections of well screens and a riser pipe above it into an irrigation well that they are constructing. The photograph on the right shows a well where the upper portion of the well has been excavated, and the pump installer is installing something at the bottom here called a pitless adapter. Pitless adapter connects the pump with a pump column to the top of the well and conveys the water out of the well into the building. The pitless adapter is installed below frost line, so in the interior, it's probably 2 or 3 meters below ground, and along the coast here, it's probably 1 or 2 meters below ground. Here you could see from the excavation, the surface seal, what it looks like in real life, the production casing, the well stick up, and the well cap. The well record. This pink picture of a well record shows a well record issued by the government. It's a record that the drillers use to record the information that they see when they're drilling and the works that they construct around the well. This particular well record has had this format since around the year 2000. Older well records will have slightly different formats. In this well record, the driller provides pretty much all of the information, his observations, his construction of works. Where I've highlighted with the red box here, this part of the well record shows the location of the well, either by parcel or legal description, or by UTM or Latin long coordinates, and also maybe even a verbal description of where it's located. In this case, 75 feet from the front of the house. This part, middle part of the well record, shows the lithology that the driller drilled through. The driller will record the depths that at the top where the material was encountered, and at the bottom of where the material was encountered, and basically log the entire hole that they drilled through. And this tells of the sediments that they went through, the type of rock they went through, and the water-bearing characteristics. Just below that panel is the casing details. And in this case, the casing extends 2.5 feet above ground, all the way down to 56 feet below ground. It's a 6-inch diameter casing, 6 5/8 actually, with a thickness of 0.21 inches. Below that are the surface seal information. This one has the surface seal length of 22 feet, The thickness of the surface seal is 2 inches, and the surface seal material is bentonite clay. Over on the right are the details of the screen intake. And in this well, the screen is open to the ground at 55.5 to 59.5 feet, and it is made up of a 0.035 or 35 slot screen. A 35 slot screen means it is 35/1000th of an inch, similar or just a little bit thicker than your Visa card. That's the opening that allows water to pass through, but not the sandy sediments. Further down are the final well completion details, the final depth of the well at 59.5 feet, the stick up of 30 inches, the static water level in the well. The resting water level in the well is 26 feet below ground, and the estimated yield by the driller of 30 gallons a minute. At the bottom here are the yield estimates. The driller here blew out water and air for 5 hours to develop the well and estimated the well yield to be 30 gallons a minute. At the bottom, the date that the well was drilled. At the top here, on the upper left or upper right, is the well ID plate number. This is the number that of a stainless steel plate that the driller attaches onto typically the production casing. On the upper right of this well record is the well tag number. This is the number assigned by the province in the GWells database for that record. These two numbers are not the same. The well ID plate number can change over time. For example, when your well is vandalized and somebody rips the plate off, then you ask the government for a new plate and you can attach it on. The well tag number is almost like your social insurance number. It's given to the well record and it stays with the record for life. Wells are most often referred to either by the well tag number, the well ID number, or the name of the well, like Main Street Well. The type of reference will depend on who's referencing it. For water operators, it's typically the well ID plate number or the well name because they know where it is. And for hydrogeologists like myself, maybe who are doing a little more regional studies, we tend to refer to wells in our reports by the well tag number because that one never changes. So here we have the well record that we just saw on the previous page. I always find it really helpful to translate the information from the well record into a diagram. And here I've done that for this particular well with the well tag number 129976. And you could see the depth of the well is 59.5 feet. The screen ranges from 55.5 to 59.5. The diagram also shows the different lithology that the driller went through, the depth to water level, and the stick up. And this diagrams the well itself, the works related to the well, the surface seal, as well as the lithology. And the lithology shows you that the well is completed into a sand and gravel aquifer. There's a little bit of a clay gravel above it, and then above that, it's all pretty permeable sand and gravel all the way to the land surface. If we look at the basic components of a bedrock well, a well completed into a bedrock aquifer, the components are pretty similar but slightly different. We have a well cap, stick up of the casing, the surface seal, and a production casing. However, the production casing is only cased to the top of the bedrock or driven by the driller maybe up to a meter securely into the rock itself. Below that, the rock is usually competent and the hole will stay open and is not cased. Open holes, however, rock chips can fall down the hole. So in some bedrock wells, the driller will install PVC liner inside which will house the pump, because you don't want any of these rock chips to fall down and wedge the pump into the hole. Near the bottom of the well is usually where in the open hole where the driller records where the water-bearing fractures are located. And this diagram shows the location of the water-bearing fractures and their depths. It's good practice to never pump the well to below the uppermost major water-bearing fracture, because this will dewater the fracture, lower its permeability, and alter the natural water chemistry. This is another well record of a bedrock well around Mill Bay, and I've diagrammed it, and you could see the top 92 feet is all sand and gravel, with maybe a bit of water in it, but the driller went deeper to 300 feet, found a water-bearing fracture at 252 feet that he rated at 50 plus gallons a minute. From 92 to 300 feet is granite, and he installed a PVC liner 8 inches in diameter, slotted from 220 to 300 feet. The water level in the bedrock is 92 feet below ground, coincidentally the same depth as the contact between the gravel above and the bedrock below. Now, why do we need to diagram it? Because rather than reading information off of a log, this is all pretty visual, and it allows you to get a better understanding of what the well looks like. And maybe for a water well, for a water operator who knows quite a bit about the well, this is not a big deal looking from the well record. But for anybody else, like the administrator and people that know less about the well, this may be a very good picture. And having a picture like this could help you know where problems may be occurring when they do occur. So if you don't have a well record, you could search for it on the province's GWells database. For example, you could search for it either by the well ID plate number that you see on your well, strapped around your well, like right here on the right, or you could navigate in the government's GIS web application, if you know exactly where your well is, to zero in on that well. Let's try and just quickly do both. Let's go by well search, and let's search for the well with the well ID plate number 53503. So if we search for that, I hope you can see when I hit the link, I come to this site. I hope you can see it on your screen. And I guess I've already forgotten the number. It is 53503. So if I hit 53503 in the search criteria, I'm either searching well tag number or ID plate number, and I hit it. The search returns a couple of wells, one in Quesnel and one in Mill Bay. And it is the well in Mill Bay that I'm really interested in, because 53503 is the well ID plate number, the plate that I see on the ground. And when you click on this, you get to the well record with all of its lithological and construction information. And at the very bottom is a link to the paper record that the driller submitted. Okay. Alternatively, what we can do is search for a well record by using the Water Resource Atlas or IMAP BC. In both of those cases, both of those applications are very similar. IMAP BC has slightly more non-water related information. I hope you can see the map of southern BC here. This is the Water Resource Atlas put out by the province of BC. If I go to water wells and bring up the groundwater well layer, and I go down to land ownership and bring up the parcel properties, I can go and search for my well here in Mill Bay. I have to know exactly where that well is in order to find it, but I know it's on Newick Road. I know it's near the highway, and I know it's these two wells. I can also go to this the little button down here and turn on the imagery, and I could see the water tower right here and the two wells right here. I can go to the identify button, click and drag it over these two wells, and it is the well just slightly to the north with the well tag number 119110. I click on that, and I click on the link to the well record. It takes me back to the same page as before. So I'm going to close these and go back to the presentation. So if you I do recommend diagramming your well. If you need help, find somebody who can, help you do that. It's based on the information in the well record. There are some wells where if there are no records available, you might have to diagram it based on all that you know, which might be the diameter, the stick up, and so on. But at least the diagram will show you what you know and what you don't know. I would put the diagram in a vertical scale to map in the lithology and the depths properly to scale. I would diagram the casing, the screen, the cap, the surface seal, the lithologies, the water bearing zones, and the groundwater level. A diagram really allows the construction of the well, the geology, and the source aquifer to be visualized, not just by the operator, but by everybody else who's not so familiar with that well and that location. So if you look at the diagram on the right, this is a well that I diagrammed for a well near Nicola Lake, BC. It's an Indigenous community well. You could see that the yellow sand and gravel that was encountered during drilling down to 21 meters, this is a shallow aquifer that's mapped by the province. And drilling basically encountered a thick sequence of clay and silt with a little bit of sand in between, and then below the clay and silt, till. Clays and silts and tills are not very permeable. They prevent water from flowing through them. And the well actually is completed into a deeper confined sand and gravel aquifer that is not mapped by the province. So having a diagram like this can show you which aquifer the well is sourcing from. It also can show you that while the upper aquifer may be quite vulnerable to any human activities at the land surface, the lower aquifer is quite protected by a thick sequence of silt and clay. So communicating the risks of your well comes across a lot better in a diagram than in a well record form. So a couple of definitions before we leave the first item here about your well. An important definition is drawdown. Drawdown in your well is really the static or non-pumping water level minus the pumping water level. What's the difference between the two? The static and the water level at pumping, how much it is drawn down. The total available drawdown is the water column that's in your well between the non-pumping or static water level and the top of the screen or the top of the water-bearing fracture. It indicates the amount that you could draw the water level in the well down to produce water that you need for your supply. Safe available drawdown is 70% of the available drawdown, with the bottom 30% being reserved for harsher, drier conditions and for housing the pump. And so usually when we rate the capacity of a well or we pump a well, we only allow it to draw down to 70% of what is totally available with respect to its available drawdown. So how do you figure out available drawdown from a well record? Well, you can go and look at the top of the screen in this well log that we've looked at and the groundwater level, and you can find the difference between the two. Or you can go to your diagram and look at it. The static water level is at 26.5 feet. Top of the screen is at 55.5. Total available drawdown is 29 feet. With the bedrock, same thing. You can get that directly from the well record, or you could deduce that from your drawing. So from a static water level of 92 feet and the uppermost water-bearing fracture at 252 feet, the available drawdown in this well is 160 feet. So concluding for the first item, there are two main types of aquifers, unconsolidated and bedrock. The construction of the wells are slightly different when you're constructing a well into an unconsolidated versus a bedrock aquifer. Many wells are registered in the GWells database. Records of unregistered wells may be obtained from the well owner or the local driller. This can be challenging because you will need their cooperation. And Diagramming a well is useful to visualize its construction methodology and to determine available and safe available drawdown. Okay, let's move on to the second item, which is learning about well yield and well performance. How is water yielded from an aquifer when the well is pumped is something we'll look at. The difference between something called an aquifer or formation loss versus well loss and how they affect the efficiency of the well to pump water out. We're going to look at drawdown, which we've already kind of touched on in the beginning, and we're going to look at something called the specific capacity, which is an indication or a reflection of the well performance, the ability for the well to be pumped. And then finally, we're going to look at how well capacity is calculated using the 100-day method developed here in BC. So as a new water operator who doesn't maybe totally is just getting understanding on your well, you may wonder what the well yield of your well might be. And there are different ways to find out. One way is from the driller's record, the estimate of well yield from the well record. Another may be the capacity of the pump that's in the well. Both of those are pretty simple to get once you can find the well record and information on the pump. Really what I want to get to in this item here is the third method, which is test pumping your well. And this is usually done when the well is first drilled before it's put into production. It's usually done by a contractor like a pump installer under the supervision of a groundwater consultant. And when you test pump a well, you are doing it under controlled conditions. You're measuring pumping water levels, static water levels, and calculating drawdowns and specific capacity. So I want to get into that third method a little bit here in this presentation. Many operators may not be involved in a full-on pumping test, but in measuring specific capacity, you will have to do many of these tasks, maybe over a much shorter time period anyway. So it's good to know. So some key definitions for this part of the presentation. We've already talked about the static water level or non-pumping water level in the well, the pumping water level, and the drawdown. The fourth and important definition is the well specific capacity. Specific capacity of the well is the pumping rate divided by the drawdown. Okay. So let's look at what happens when a well is pumped. When you pump a well, you're lowering the water level in and immediately around the well. And this causes a gradient to develop around your well. And this hydraulic gradient, this pumping and lowering of the water level increases this hydraulic gradient. And this gradient drives groundwater towards the well that's being pumped. The gradient is steepest at the well and decreases away from the well. And that's because the cross-sectional area through which water is flowing to the well is ever increasing as you go farther and farther from the well itself. So in effect, pumping creates a vortex, a lowering in water level, a lowering of the water level in the aquifer, and it looks like a cone of depression or a cone of drawdown around the pumping well. This is a cone of depression of the water level and a cone of depression of the water energy that is around your well as your well starts to pump. And this cone of depression grows at an exponentially decreasing rate beyond the pumping well as pumping continues. And a tip, as long as the pumping water in the pumping well is dropping, that is indicating to you that the cone is continuing to grow laterally beyond your well. Oops. Next one. So in a pumping test, this is kind of what the water level looks like as you go through a pumping test. Prior to the test, the water level is at the static level, non-pumping level. You want to take measurements of the non-pumping water level. And then when you turn the pump on, right here in the beginning, and this is a graph showing depth to water below the well and the elapsed time since pumping started. When you first start the pump test, water level in your well drops very quickly, and the drop will continue, but the rate of drop will decrease over time during this pumping phase. And the difference between the original water level before pumping and the pumping water level anytime during the pumping phase is the drawdown in the well. Now, when you turn the pump off, typically a well is pumped at a constant rate for 24 or 72 hours. If after 24 or 72 hours you turn the pump off, the water level in the well will recover very quickly and then continue to recover, but at an ever decreasing rate during the recovery phase. Water levels are monitored in the pumping well, and if you have an observation well nearby, monitor that in that as well in a pumping test. And monitoring continues after pumping stops into the recovery phase. Stepping a little bit aside for a minute, I'm going to just introduce what I mean by aquifer loss and well losses. So when you pump a well, water has to move from the aquifer towards and into the well. And when it moves towards the well, that groundwater is losing energy and the water level is gradually dropping more and more towards the well. This loss in head of the groundwater as it flows to the well is called a formation or aquifer loss. It's just the natural loss of energy as water comes towards your well. But at the well itself, the groundwater will lose additional frictional head loss, moving from outside in the aquifer to into the well stream. And this additional frictional head loss may be caused by damage in the aquifer formation around the well from drilling that has never been healed. It could be from inefficient screen design, like the openings are too fine or it's clogged, or insufficient well development or over pumping, right? And so the well wasn't sufficiently developed for the screen to do its work. Now, if there was no well loss, the water level in the well would be where this blue line is. As the aquifer losses reach the well, just inside the well, this would be the pumping water level. But with well losses, you have additional drawdown because water loses energy coming into the well, and it's designated by this red line. And so the implication of well loss is that this loss takes away available drawdown that could have been used to pump more water out of the well. And so this well loss is an indication of the inefficiency of the well. A 100% efficient well would have zero well losses, and anything less than 100% will have some frictional head losses as the water enters the screen. Back on track to the specific capacity, it is the pumping rate divided by the drawdown. Specific capacity reflects the productivity of the aquifer. It also reflects the efficiency of the well itself. It's a really good indicator. And specific capacity is a function of time since pumping started, unless the cone of drawdown and the pumping drawdown stabilizes. So when you're comparing specific capacity from year to year, when you're monitoring your well's performance, it's important to reference that with respect to time, like how, when you measure the specific capacity, is it after 1 hour of pumping or 24 hours of pumping? So the time reference is important when referencing and comparing specific capacity from different tests. A decrease in year to year in specific capacity indicates that your well's performance is declining, right? And your efficiency is becoming more and more inefficient. So how does that affect well yield? Well yield is a product of the specific capacity and the available drawdown in your well. In fact, it is well yield in BC is calculated by using the safe available drawdown, 70% of the available drawdown in your well, times the specific capacity usually determined for 100 days of continuous pumping. So in a pumping test, you will measure the drawdown with time. And this is a graph showing drawdown, zero drawdown at the top in the vertical axis, and drawdown increasing vertically as you go downwards, kind of like the pumping water level dropping. And then if that's plotted against pumping time, this is a 25-hour pump test, so up to 1,500 minutes. You could see the drawdown increases very fast in the beginning, and the rate of drawdown slows down but continues to increase over one day. Now, instead of plotting drawdown with time, if we plot it with log of time, this curved line becomes more or less a straight line. And if we were to calculate the well yield, we would extrapolate that straight line to 100 days of pumping. 100 days of pumping is 144,000 minutes. So like this graph shows, specific capacity will change depending on the length of the pumping time. After 1 hour of pumping, so 20, 30, 40, 50, 60 minutes of pumping, the drawdown in the well is 3.1 meters. If it's being pumped at a controlled rate of 736 cubes per day, the specific capacity after 1 hour is 237 cubic meters per day per meter of drawdown, or meters square per day. If you extrapolate the pumping to 100 days, the drawdown is expected to be 4.2 meters. And the specific capacity at 100 days, after 100 days of pumping, is expected to be 175 meters squared per day. So when you talk about specific capacity, referencing that time of the test is important. So how do you calculate well yield using a 100-day method? Well, you do a pumping test. You determine the available drawdown in your well from your well record. You plot the drawdown versus time, but logarithm of time. You extrapolate that drawdown behavior to 100 days. You calculate the specific capacity at 100 days. And then you calculate the well capacity by taking 70% of the available drawdown and multiplying it by the specific capacity at 100 days. So this is how consultants and government rate the long-term yield of a well, right? It assumes the well will be pumping 24/7 for 100 days straight. You may or may not do that when you're operating your well, but this is how the well is rated by hydrogeologists. So here I have an illustrative example of the 100-day method. This is a well that I oversaw the drilling of. It is roughly 282 feet deep. It is screened in the entire aquifer, which is found at 258 to 285 or 282 feet. The static water level back in 1987 was 47.7 feet. So the total available drawdown in this well is 209 feet or 63.8 meters. We went after the well was drilled to pump test the well, and this is a 24-hour test, and this is a plot of the drawdown in the well versus logarithm of time. When you extrapolate the pumping behavior all the way to 100 days, it is just a little bit above the safe available drawdown in the well. So the pumping rate is 624 cubes per day. The projected drawdown at 100 days is 37 meters. The specific capacity after 100 days is 624 cubes per day divided by 37 meters, or 16.9 cubes per day per meter. The well yield is 70% of the total available drawdown times the specific capacity at 100 days, or it's 754 cubes per day. Now, I couldn't really rate the well at that rate because I never pumped it at that rate. So the practical well yield will be 624 until we can pump the well at a high enough rate to verify this long-term yield. But in essence, this is how a consultant would calculate the long-term yield of a well. You see the first few minutes, there's actually over 10 meters of drawdown, quite a bit. I'll bet you a lot of that is probably well losses because the well wasn't 100% efficient. And so how do we quantify or estimate well inefficiency? Well, the well inefficiency is the ratio between the drawdown, if there was no well losses, divided by the drawdown when there is actual well losses. And so if you look at the pumping test data here for another well, within the first 30 seconds of pumping, the water level's already dropped over 1.5 meters. So to me, this is probably quite a bit of it due to well losses. And then, so if that is around 1.5 meters of well loss, then all of these other water levels, when you're pumping the well, should probably be about 1.5 meters less than what's actually measured. So if I was to calculate or estimate efficiency of the well, the drawdown in the well when there's no head losses divided by the actual drawdown, I'd probably take the drawdown, let's say at 10 minutes, 7.95. If I think there's about 1.5 meters of well losses, then I divide what I think would be drawdown unaffected by well loss divided by the actual drawdown, which is affected by well loss, and I get something like about 80% efficiency. So while there is well losses in every well, a properly designed and developed well should be at least 80, 90 or more % efficient. Okay, let's go on to the third item. Explain how to measure specific capacity, understand some of the causes of declining well performance or well inefficiency, know when to act to rehabilitate a well, and appreciate the distinction between declining performance or other external factors that might cause a decline in your well yield. So to measure performance over time, one thing I recommend is monitor the specific capacity from year to year. To measure the specific capacity, pump the well at a controlled rate. Usually the maximum well rate that the well is rated, or the rate at which the well was pump tested, because you have data, for a specified time. Doesn't have to be long, half an hour, 1 hour, 2 hours. Measure the static water level prior to pump the test. Measure the pumping water level after the specified time. Calculate the drawdown. Calculate the specific capacity after that specified time, which is the controlled pumping rate divided by the drawdown after the 1 or 2 hour period that you're specifying. And repeat this procedure on a regular annual basis, same time of year, same kind of controls, so that your numbers can be comparable year to year. Plot the specific capacity over the years and compare it with the original specific capacity. Is it decreasing? Is it increasing? Is it staying the same? So it's important to always keep the original pump test reports from the consultant, because the original specific capacity can be found there. So let's look at performance of the well over time. Initially, when the well is drilled, the well driller is also doing specific capacity tests as he is developing the well. The well in the beginning, when it's constructed, is not very clean. He needs to develop it. And as he's doing that, he's pumping the well and measuring the pumping water level and the drawdown. And as he's developing the well, the specific capacity and the well yield will continue to increase, and the pumping, the drawdown and the pumping water level will decrease to a point where he can't do much more. The well is as optimally developed as it can be. Hands the well over to the water supply system, and then you put it into operation. If you monitor the specific capacity over time, you may in time see the specific capacity dropping. And if the specific capacity is dropping, it means your well yield is dropping. And when it drops by more than 10 or 15%, you should get your water supply system to budget for hiring a consultant or a driller to rehabilitate the well. When you bring in those professionals to do it, they can bring the well back up to its original capacity and you continue on your merry way until it starts to decline again. And then you can bring in the driller or the consultant again to rehabilitate it. If you keep track of your performance over time, you will significantly lengthen the life of your well. If you don't measure specific capacity, or you measure it but you don't look at it, or you bring in the driller or the consultant at a later stage, the well may be bad enough that they cannot rehabilitate it back to its original condition, and you've shortened the life of the well and decreased the yield of your well for good, right? That's indicated by the red dropping line here of neglect. What causes performance decline in wells? Well, it could be incrustation of the well screen. It could be carbonate incrustation. And I'm not going to go into it here, but you can click the link. And if you have a water chemistry sample of your well, you can plug in your results and it will calculate how hard or how encrustive or corrosive your water is, your well water is. There's manganese and iron in the water that can facilitate bacteria growth. There's biofouling of the well screen. There's plugging of the well screen because of inadequate design, inadequate development, or corrosion causing enlargement of these slot sizes and causing sand and clay and silt to come into the well to clog the screen up. So biofouling, sediments coming in, iron oxides and sulfides, all of these can be problems, but these problems will be diagnosable by the consultant and the well driller when you bring them in. So how would you deal with them? You could physically redevelop the well by scrubbing, brushing its teeth, kind of like, or surging or bailing or jetting or airlifting. You could put acid in the well to get rid of the incrustation. You could put bactericide in the well to kill the bacteria. You could use heat to kill the bacteria, or a combination of the above. Or if it's a well screen design problem, you could reinstall a new screen, or you might have to drill a well next to it altogether. The important thing is to consult a professional when your performance of your well is declining. And if you leave it too long, for example, the incrustation, the bacteria could grow beyond the well screen into the aquifer itself, in which case it makes it much harder for the driller to put any kind of treatment beyond the well into the aquifer to clean up the problem. So factors causing a decline in well yield. This is the last part of our presentation. A year-to-year decrease in specific capacity reflects a decrease in well performance, which causes a decrease in well yield. And this is something as an operator or well owner you can control and measure. The other factor that causes your well yield to decrease is a drop in available drawdown. And again, as a water operator, you can measure the static water level in your well and see if it's gradually dropping over time. If it is, it means your available drawdown is dropping and your well yield is dropping. But there are other external factors related to available drawdown. You could have interference from nearby pumping, or you could have a regional decline in groundwater level because of drought or because of over pumping. With the well interference, if you do have a water license and you do have priority over your neighbors in terms of water rights, you could contact the government and tell them you're not able to exercise your rights because you don't have the available drawdown to draw the amount of water that you need under your license. Then the government will come in and do something about that. If it's a regional groundwater decline, it is a more complicated problem involving a lot more other water users. Second to last slide here. This is a well, a case study of a well I drilled in 1984 for a fish hatchery in the Kootenays. Within a year, I got complaints that the new well's yield has declined after 1 year of operation. Keep in mind, whenever you're dealing with the well yield is a product of the available drawdown or safe available drawdown and the specific capacity. So I went back to this hatchery well in 1985 with the driller, fully expecting that I would have to rehabilitate the well. I took the major information from the well from when it was first newly drilled in 84, and then I went and measured those same information when I was on site. So originally, the well was a flowing well. The water level in the well was above ground. When I came back a year later, the water level in the well was 12 meters below ground. The available drawdown was originally 39.5 meters. Because of the lowering of the static water level, a year later, it's dropped down to 27.5 meters. The specific capacity I got from the original pump test, we pumped the well for an hour, and I got a specific capacity of 131 cubic meters per day per meter of drawdown. From the original test, the data showed the specific capacity was at 129. Very, very similar. If well yield is available drawdown times specific capacity, the original well yield is 1,800 cubes per day. The well yield after 1 year is just a little over 870. No new wells nearby originally, no new wells a year later. There were no sediments accumulated in the well. It was properly developed, but there was some bacterial growth in the pump column. But in the end, what I deduced was the performance of the well has not changed because the specific capacity has not changed. What has changed is that the available drawdown was lowered significantly. And so this aquifer was a virgin aquifer with a higher head. And after 1 year of using it, the aquifer water level basically declined to a new equilibrium of 12 meters below ground. And so the long-term yield of the well, unlike what was determined by the pump test, is actually quite a bit lower from operation, living it out in operation. I think in the end, this wasn't enough water for the well hatchery to use the well. So I don't think they use the well any longer at this hatchery. And that's it. I just wanted to end by summarizing that it's important to know your well, to get the well record, to diagram your well. It's important to track specific capacity in your well to track its performance from year to year. It's important to understand that well yield or well capacity is a product of the safe available drawdown in the well times the specific capacity of the well. And if you measure the specific capacity of your well and it's decreasing from year to year, there's something wrong with the performance. And if you're measuring static water levels from year to year and it's declining, then there's something wrong with the aquifer. So measuring those two things, water levels and specific capacity, will help you distinguish as an operator, what is the problem? Is it your well or is it an external problem? And that's it. Thank you so much for your attention. I hope I'm in time. And I'm just going to go off of presentation mode and hand the floor back to Sitwinder.
Thank you, Mike, for that incredibly informative presentation. We will now open the floor for questions. Please use the chat feature to submit your questions, and I will read them aloud to Mike, and then Mike will respond by voice. Mike, I get the privilege of asking the first question. In BC, we've been experiencing these long periods of drought. So, what are some of the important operational strategies we should be looking at when we're, running our well? Like, what should we be considering to make sure that we get some level of, water quantity and so on, and periods of drought and so on? So.
Okay. So a few things come to mind. One is, are you using that water efficiently? So how is your water demand? So you can work with your irrigation district or waterworks district to make sure that your customers are not overly using water. Another thing may be look at how efficient your well is. Could it be made more efficient and you can pump more water out of it if you need? Or do you need to deepen your well? There are many wells in older communities that are dug wells that are only dug into the top of the aquifer. Well, no, you're not using the entire saturated thickness of your aquifer, so you might have to improve your works. Thirdly, you may need storage so that you could pump during wetter times of the year and store that water to be used during drier times of the year. And fourthly, and just as important as all the other technical stuff, do you have a water license that authorizes you to actually divert and use that water? Because during times of scarcity, when the government has to come in and regulate use, if you have a water right, you at least have some priority to use that water. If you have no water right, you may be out of luck, right? And so while it's easy for me to sort of name the top four things you could do, storage, maybe deepening your well or using your well more efficiently, especially with things like deepening your well or storage, you really need to work with either a consultant, groundwater hydrogeologist, or your civil engineer to see like whether you need that or not, right? Because it does take money to construct storage. How much storage do you need, right? So the problems are always specific to your system. And while it's easy for me to name the general solutions and strategies, implementing that strategy will require help from those professionals that you work with.
Yes,
Can I
definitely.
say one more thing? I forgot to promote something. If you are interested in water rights and groundwater, I am going to be at the BC Groundwater Association convention in early April. The day before the convention on April the 8th in Kamloops, I will be, the BC Groundwater Association will be sponsoring a one-day course on water rights for licensed groundwater users. Cost is $200. It will be in Kamloops, and I've put the link to the convention and registration for that course on the chat. Yeah, other questions?
Okay, I have a question from Reed. Why do we have a WTN and a WPN? Why these two different numbers?
Because we have a difference between a well ID plate number and a well tag number because both of them happen at different times in history. When the government stopped relying on paper well logs and filing them and developed a database for it, the well tag number came into being. And then probably a little bit time later, when the groundwater protection regulation came in, and the idea of identifying the well on the ground, that it would be good to have a plate number to use the ID plate number. However, the plate number can change. The well tag number doesn't change. And so when I was working in government, we kind of wrestled with the fact that, you know, is every time a plate is vandalized and we ship out a new number, we're going to have to change the well tag number? We thought, no, that's just work that we can't keep up with. So apologies, but they are two different numbers because one of them can change and the other one, we don't want it to change.
Okay, thank you,
By
Mike.
we, I mean we when I was working for government.
And we have posted your event in April on the website. So for more in-depth information, please check out our website for the workshop information. Next question is by Eric. What type of equipment would you recommend for monitoring well performance?
For well performance, you would need your pump that's already in your well. You would need the ability to control the rate of your pumping so that it's constant. Many wells in water supply system wells will have an access tube so that you could lower down a water level probe to measure the water level. And because you don't want that probe to be wrapped around your pump columns and your rope and everything and get it all stuck. And many water supply systems have a transducer data logger already installed in your well that's already reading the water level. So if you have more of a like a data logger setup, you can pump your well at a specified rate and get the readings off of your data logger, or manually measure your data logger with your water level with a water level probe, which many water supply systems should be equipped with. They're not cheap; they're over $1,000 now. But you need a water level meter, probe. You need an access tube installed in your well. You could have a data logger if you already have one, and you need the pump and a way to specify a constant quantity for constant pumping rate. So things that I think most water systems would be equipped with that are reliant on wells.
Okay, thank you. Kimberly asks, in your talk, you did not mention shock chlorination as a way to improve the well water. What are the effects of shock chlorination on drawdown and water yield? Actually, this was one of my questions. For the longest time, we've been taught about, especially if there's a microbiological contamination or something like that, to do shock chlorination. So what is the best practices or intelligence on that now?
Well, I'll preface the response by saying I probably didn't include every technique out there, and I'm certainly not a specialist in um, chlorination. I think you probably have to talk to a water treatment person or a water operator. My understanding is the chlorination will shock and get rid of the pathogens in there and the bacteria. I guess an important question I would ask back is, do you know what the cause, what the source of that bacteria is? Is it just a one-time careless introduction into it and you're pretty good? Or is your well water and the nature of the aquifer prone to promoting bacterial growth, right? And you would probably shock chlorinate it, or um, I guess a bactericide is kind of like a shock chlorination. You're killing something,
Yeah.
but I don't really have much more comment or insight into that. But if you shock chlorinate, you probably will have to do it on a recurring basis, right?
Yeah.
Unless it was something introduced one time due to carelessness.
Yeah. Usually, microbiological contamination will lead to a well closure, and you will have to find an alternative water supply. But most of the well developers tell us that they don't recommend shock chlorination any longer. I mean, of course, they hygienically clean the well after it's developed and constructed, but not after that. So, yeah.
Yeah. And you might want to ask them why.
Okay.
I know a few years ago when I was dealing with a well, we were considering fracking. This was to increase its yield. And I didn't realize when you frack in a shale formation, you can cause havoc in neighboring wells, right? And cause their water to go dirty as well. So it depends on the formation and the circumstances. And one of the reasons I asked was, well, why couldn't we do that, right? Well, it's shale. When we frack it, we could get other people's well water all dirtied up and their laundry completely, discolored. So unless they're far enough away, we don't really want to do that, right? And that may not be the case in, say, a granitic aquifer.
Okay.
But yeah.
Michael asks, have you ever had to deal with the cavitation of a pump due to high use, thus brown water?
No, Michael. One of the things I should have qualified right off the beginning is I am an expert at some things, but I'm not an expert at everything. And certainly the stuff that water operators and contractors deal with, it's not what I do every day, right? What I do every day is look at specific capacity, look at pump test data, and look at hydrogeology and well records. So no, unfortunately, I do not have that experience to kind of share with you on the spot here.
Next question is by Mike. Can cameras be used to inspect well screens?
Yes, I think if you contact your local pump installers, some of them may have downhole cameras and others may not. But they can send a camera down there to take a look at the condition of the well, which is something I didn't have 30 years ago when we were doing when I was doing my drilling then. But yeah, certainly if you contact pump installers or pump testing contractors or even drillers, they might have a downhole camera.
As an operator, we can take the data from the well, but we can't do any rehabilitation or nothing. We are to contact a well driller or pump installer to come do the rehabilitation. So as an operators, we're not allowed. So
That's a good point. Drilling and pump installation are restricted activities in BC. You need to be a certified registered driller or registered pump installer or a PNG or PGO
yeah.
to take responsibility for that work.
Okay. We have lots of questions, Mike. So here's our next question from Catherine. Do you have a comment about different methods of redevelopment? Is surge and bale better than air burst, for example? I ask because there's quite a difference in price. Yeah, there you go.
Granted, I think the answer to that really lies in what is causing, what is the thing you're trying to redevelop? Are you trying to get rid of incrustation? Are you trying to get rid of bacteria? If it's just well development, um, I would ask the driller or the consultant because these methods are very specific to what your well is experiencing. I've always learned from textbook that jetting is really good, but that's from experiences from all over North America. When I was drilling wells at a younger age, drillers would tell me reasons why they would not jet, partly because they don't have the equipment and partly because they don't, some of them times they don't think is very effective. And so really, I would ask the driller why one is better than the other. And because it's sort of outside my expertise and your expertise, you're going to have to use your critical thinking to see whether the reason that the driller gives is pretty reasonable and valid because there is a price difference, right? But
Yes.
there is no guaranteed method A is better than method B. Always do method A. There is a reason why somebody recommends method B, and it may be because that's the equipment they have, or it may be because there's actually a really good reason why they're recommending uh, method B. Dig for that reason in order to inform you on the price to the money to spend.
When we're talking about biofouling, we're mostly talking about iron and sulfur reducing bacteria. Is that what we're talking about when you're talking about the biofouling in
Yeah,
this? Okay.
yeah.
Marx asks, when did drilling become regulated in BC, i.e., drillers operating to standards and regulations?
Well, BC had never had any standards for drilling up until the year 2003, 2004. And that's uh, reasons for that are probably varied, but the tragedy at Walkerton really triggered every province across Canada to ask, what are we doing about protecting our water supply? Do we have that barrier out there? And BC said, no, we don't. Anybody can drill a well and anybody can install a pump. So it was after Walkerton that the government of the day decided to update the Water Act to give authority to the government to regulate drilling and pump installation. And that came in 2004 with the first version of the groundwater protection regulation. And so
Regulation.
prior to that, drillers didn't really put in surface seals. There were no minimum stick ups. And I'm pretty happy to say that after 20, 25 years, installing a surface seal is a de facto practice. We've improved the practice um, for drilling these wells and making them better protected against unintended contamination like that.
Well, having the groundwater protection regulation has brought us so far, along. Like before, it was just pump your well till it run dries. So we're very grateful about the groundwater protection regulation and what it's done for the safety of groundwater in British Columbia. So with proper setbacks, all guidelines for developing wells and constructing wells and so on. So
Glad to
um,
hear.
Brian asks, how do you constantly know its depth? Meaning the depth of the water in the well, Brian?
Right.
Yeah, water depth, that is. Yes. He's asking
If
about.
it's the water, if it's the water depth, you probably noticed that in the presentation, I referred a lot to the well record and the original depth, right? 26.5 feet, 92 feet. If you were operating a well system, you should be measuring pumping water level depths and static water level depths all the time, either typically with a data logger installed in your well, right? And so that's where you would get it. You would download it and plot it up and see if it has been declining over the years or declining since the first when the driller measured it. The driller's measurement can be pretty accurate and it can be not very accurate, particularly for bedrock wells. They usually will leave the site, tear down and leave the site, but the water level in the bedrock well is still recovering. So sometimes the water level in the bedrock well reported by the driller is actually deeper than what it is after the well's fully recovered. If you didn't have a data logger, you would measure it with a water level probe, and you would ideally have an access tube that protects the probe from getting tangled in with everything else.
Okay. Question from Bob: Are there any regulations in place to protect wells or aquifers from contamination, as such as backflow prevention?
I'm not as familiar with the Drinking Water Protection Act, obviously, but there are uh, requirements in the Water Sustainability Act to keep junk away from your well or wellhead, right?
Yeah.
Surface seals to be installed, stick ups, flood proofing your well. And I think if you have an artesian well and you want to bring it under control, you need to have a backflow prevention from that water that's come out of the well to slurp back into the well. So there are various ways in which contamination protection is, um, I guess, implemented through stick ups, surface seals, caps, just keeping junk away from your well, sloping your wellhead so that nothing flows towards your wellhead, but rather away from your wellhead. So those are all things. Now, you brought up a good point about protecting. If you look at the bigger scale beyond the well itself into the aquifer or the watershed, then that becomes more of an issue of source protection of the aquifer itself. And I think larger water supply systems may be required by the drinking water officer to develop well protection plans, right, for
Yes.
their wells. In which case, the system would hire a consultant. They would look at the well record and geology around the area to look at the vulnerability of the land and the risk to contamination, and then they would maybe inventory the land use around the well to try and identify uh, what the likely highest threats are going to be. Is it salting from the highway? Is it the fact that you have a low stick up and you need to upgrade it? Is it the whatever it is that's up gradient from the well, right?
Yes. Question from Angela. If an operator is measuring the specific capacity and comparing data points year over year, is there a particular time of year they should be doing this? And then part two is assessing the suitability of a new well source, how important is it to have the initial pump test carried out during a dry season?
Okay, so two parts of that question and two parts of that answer. First of all, measure the specific capacity. Yippee-yi-yay if you do it. Do it at the same time of year. my first thought would be probably a couple of considerations. Maybe do it when the well isn't in a lot of use. That way you're not getting a lot of you're not running into pumping periods and so on. Or do it when it's in the drier or average time of year, not super wet time of year. But do it and stick to the schedule that works best for you, right? I think when your well is not being used, it's probably a good time to have a truer static water level. And in terms of a new well, yes, for bedrock wells, if you were to apply for a water utility license or a water license, I think the government would really like it if you pump tested the well during the dry season. So here on the coast, the we don't recommend pump testing a well when it's pouring rain like it is at this time of year. In fact, local bylaws for subdivision approvals for the regional district of Nanaimo, they will not accept any tests after October, right?
Okay.
And so a rule of thumb for locally here in the wet coast is do your pump test before the November rains come.
Well, there's so
Especially for
many.
bedrock wells. Bedrock wells are typically much more sensitive to climate fluctuations than sand and gravel wells.
Yeah, because I
We've
was
had,
wondering
yeah,
about the seasonal variations. Like the seasonal variations can be so drastic. I'm wondering if doing this specific capacity just once a year is enough. Like that's kind of what I was wondering.
um, yeah, during wet season, your well is going to yield more just because you have more available drawdown. But the performance of your well shouldn't really be affected by whether the water level is high or low. It's really affected by the drawdown, right? The difference between the pumping and the static. So I don't think it matters that much. Your available drawdown would matter, but um, I don't think you're. I think if you could do a specific capacity at any time of year, I probably prefer average or slightly drier times. Um, you're good.
Okay. A question from Chris and Lynn. What is a reasonable amount of water for a single domestic building permit where there's only one well water? When there's only,
Where there's only well water.
yeah.
I can tell you what the practices are. Um, I think for, let's say, a surface water domestic license, or even in the Water Sustainability Act, when it comes to um, looking at what a domestic quantity could be, you'll find references to 500 gallons per day, which works out to about 2 cubic meters per day. That's kind of what I think the government will issue a license for domestic. They might have changed their practices to maybe being a little more stringent. Um, but actually, how much water you use during a day is probably less than that amount. It's probably closer to 1 cube a day or less. So the actual use may not be the same quantity as what you might be authorized under the act to use, right?
Question from Brian. We had a new community well drilled in fall of 2024. When can we expect Interior Health and BC Groundwater to have final approval to use?
Brian, I'm not going to let you put me under the bus with that question. It's not a question I can answer as a private citizen. I don't work for the government anymore. I know there are longer wait times. I can't answer you. I don't even know where you are.
Thank you, Mike. David asks if we have a well that was never registered, drilled in about 1994, what are the advantages and challenges of registering the well? I expect we may not have original drilling records. So the well was constructed in 1994.
Okay. So this is a bit of a loaded question as well. I run into it quite a bit. So there are two schools of thought. There's the school of thought, particularly from domestic well owners, I don't know where, I don't want the government to know where my well is because sooner or later they'll be taxing my well, right? So currently the WSA licensing of domestic use of groundwater is not licensed. You drill a well, you put a pump in, you use it. So the sort of fear that I see from citizens is I don't want the government to know, right? If you were more than a domestic well, um, you do need a water right. It's not just given to you in the act, you have to apply for one. And so you either stay under the radar and say, I hope they'll never find me, or you go up front and ask to get your well registered and get a license. The advantage of getting your well registered, even though you're domestic, is that when the water manager makes a decision on a license, a proposed groundwater use, they will know where you are, what your intended uses are, so they can consider your right prior to issuing the license. Now, if they don't know where you are and they make a decision, and in the end, the licensee turns on the pump and affects yours, the government still has to deal with it. But it just is a little more of a mess to deal with after the fact than before the fact, right?
Yes.
Yeah. So if you've never registered it and you don't have the well record, if it's a drilled well, you could at least give them the location. If you do decide to register, you can at least give them the location of the well with like a GPS location, the diameter of the well, the stick up of the well. You could tell them what your well use is for. Is it for an RV park, for a golf course, or whatever it is? And then someday you could still register that well. It just may not have the depth or the lithology. But someday when you are pulling your pump out for maintenance or whatever, major maintenance, you could send a camera down and document, do we have a screen? Do we not have a screen? And can I sound the well to see how deep it is? And add to that information into your well record, right? And then from neighboring well records, hopefully you'll be able to determine whether your well's in sand, gravel, or bedrock, even though you don't know the intervening geology between the ground surface and the depth of your well. But it is helpful to know where these wells exist and what their water levels are, right? You can give them the water level as well, right?
Plus, 1994 is not that long away, not too far back in history. So you could look at who the local drillers are, and perhaps they may have records as well, or
Yes.
okay.
Yeah. Certain drillers are very good at keeping records and are very open to digging into their files and sharing it with you, right?
Yeah.
And then when you do that major repair, and you pull the pump, you could sound the well just to see the well record says 59.5 feet. How deep is my well? Oh, it's 59.5 feet. Or no, it's 200 feet. This is not the right well record, right?
Yes. Um, Joel asks, how long should you run your well hours per day?
Well, the wells are designed to run 24/7 for a long time, so they're built to run, right? If you need to run it for a long time, you do, and you don't. I just want to get back to the question about water rights because it's still British Columbians are still and groundwater users are still trying to get used to the fact that that water coming out of the ground on their property is not theirs and the government is regulating it. And the government may do certain levels of checking or not checking, and some people will think, well, they'll never find me, right?
Mhm.
But um, maybe think of this issue over the next 20, 30, 40 years when that property and its legacy of whatever rights they have to the water gets passed on to somebody else. I've had a number of people call me as a consultant to say, what are the likelihood of getting a license in this area? what is a license worth? How do I evaluate it so that I can register it as an asset with my bank? And so while we have historically never been too focused on water rights, over time, will we be focused more and more on water rights 10, 15, 20 years from now, as we deal with these water problems on a recurring basis?
Okay.
Now, I say this, and in the back of my mind, I do realize that um, all of British Columbia sits on unceded Indigenous territories. And so, how a water right applies to Indigenous nations using groundwater is not something that has I know and has been determined. So I do recognize when I talk about this kind of stuff, I'm talking about it from a settler's point of view, related to more clearly with settler groundwater users, right? And I don't mean to impose that view on Indigenous nations, but more so to the settler users that you're regulated under the WSA, and you got to weigh the difference between flying under the radar for now or having this water right become uh, an issue later on. But it is for the individual user to decide what to do, right, in terms of complying or not.
So Mike, it's 12:35. We still have about 200 people listening. Are you okay dealing with a few more questions?
I will until my insulation contractor comes in, and then I got to realize what's the expensive or cheap thing to do by finding out why they're doing one thing or another. Sure,
Okay.
go ahead. I've got time.
Okay. Let me know. Let me know. So we'll
Okay.
we'll keep going. Okay. Um, Angela asks, what generally better for overall well health? Cycling a pump off and on at a higher rate, or running the pump for longer cycles at a lower rate? How would you test this?
Well, I think my understanding of operating these pumps is it's probably better to gently ramp it up as opposed to hitting the well hard, especially when the well is first developed and put into operation. You don't know how stable that gravel pack around the well is. And how would you test this? Um, well, you either go hard or you go gentle, right? And what you don't want to do is go hard and go, shoot, I just kind of wrecked my gravel pack.
Yeah.
But if you have a choice, I'd probably go slow and then ramp up as opposed to going hard right off the bat.
Yeah, that's what we
And when you
always
shut it off, I guess you shut it off, right?
yeah, yeah, we always recommend that
Because
in all operations. So
yeah, because when you're shutting the pump off and you have a lot of drawdown, there's a huge gradient outside the well ready to drive that water in, right? Whereas if you pump more gently, your gradient will be less.
um, how do you monitor, Rob asks, how do you monitor specific capacity if the pumping rate is variable?
Uh, in well, I'm going to have to return the question. What do you exactly mean by that? You mean you cannot fix a pumping rate, it just starts, but so are you pumping against a higher and higher head, and that's how your pumping rate is varying? Um, I think what you want to do is try and get the conditions as constant as you can, right? So if you test year to year, will that pumping rate vary?
Yeah, Rob, I don't know if you can supplement information on your question. Are you varying the pump rate, or are you like stopping the pump and then, going off and on in pumping your
Or
well?
or is it that you have no way to control the pumping rate, and every time it turns on and the water level draws down, you're pumping against higher head and your rate always varies. But does it always kind of vary? Um,
Okay.
does it vary differently every time you turn the pump on,
He's
right?
saying he
Yeah.
runs the pump with a higher flow rate in the summer than the winter.
Yeah. So seasonally, he's,
Oh,
yeah.
I would probably recommend if you are regularly, oh, no, pump the well for an hour, 2 hours, half an hour, pump it at that constant rate at that time of year. And in your case, I would probably pump it when your well is being pumped at the higher flow rate, because when you're not stressing your well, you're not stressing the specific capacity, right? It's like driving a car. There's no problem when you're driving the car at 5 kilometers an hour. But is your car as fast as it was before? You're only going to know that by going at this, 100 kilometers an hour, right? Whether things are at the rate that you want the well to be working at. Is it going okay, right? Just like my heart rate and my health, it's not a great test if I'm just walking. I've got to ramp my breathing higher up to see if my heart's going okay. So
Yeah.
I would test it at your normal higher flow rate, um, than your lower one.
Um, changing the output of the pump with a variable speed pump depending on the demand during the year.
That I
Um,
think Satwinder, that was part of
oh,
Rob's
okay. Okay.
contribution. So there's a question from Cindy just above.
Oh, okay. Cindy asks, thank you for the presentation. With our new well, we are being required by Vancouver Coastal Health to have a level 1 water operator. What would be the requirements of this person? Actually, that's a better question for EOCP. So if you can contact Environmental Operator Certification Program, they're the one that certify operators, and they will be able to help you put a job posting out or what the requirements are. So it's a best question for the EOCP to ask rather than Mike. Okay.
Thank
Um,
you.
Brian asks, we have a well that we use very infrequently for 2 to 4 weeks, maybe twice a year. Any specific risks to be aware of or actions to take related to this usage pattern?
Well, let me think about that. We have a well that's probably like a well at a cabin or something, 2 to 4 weeks for twice a year. Any specific risk to be aware of or actions to be taken? I guess the first thing that comes to mind, and I got to preface it by saying I'm not an expert at the drinking water stuff, but first thing I would probably do is take a sample to see if your well water is good, right? Because you haven't, your well hasn't been flushed for 48, 50 weeks of the year, right? It's staying stagnant. Maybe let it run. Maybe take a sample to see if uh, there are any pathogens in the water, and then you use your well, right? But I
Yeah.
would say let it run, because oftentimes things get stagnated in there, and water flow, like airflow, uh, is probably a good thing.
Yeah.
And I'm sorry I can't be more helpful than that.
No, I think that was very helpful. Jonathan asks, what are your thoughts, recommendation regarding remote well water level monitoring? So rather than conducting a pumping test, using a logger to provide real-time readings.
Your thoughts on recommendation regarding remote water level. So rather than conducting a pumping test, use a logger to provide real time. Yeah, I mean, a logger is used even in a pumping test. A logger really is just to measure the water level at a frequency that a human cannot keep up with, right? You do have to pump the well. Um, I'm wondering if the question is, rather than doing a pumping test, can I just take the water levels that I'm logging already, and the pump is turning on and off? So can I use that data? I suppose you could, but the data can be noisy, right? Because you're turning it
Yeah.
on for, I don't know, a few minutes, and then it goes off, and then it's on, it's off. And I guess the question back to you is, can you compare your specific capacity? And I'm not asking you to do a full-blown 24-hour, 72-hour test, but 1 hour, half an hour. Can you compare that, um, from year to year. And if you can, great. Then the data you're already collecting is already collecting when you're pumping the well and when you're not pumping the well, and the water level correspondingly, right?
Yeah.
But it's just whether or not it's controlled enough that you can compare the results.
Yeah.
I think that's what you're asking.
But I think trending it over years will give you a good reference point, don't you
Yeah.
think? Yeah. Okay.
Yeah.
Tom asks, you mentioned that the well records referenced in the presentation has been generated since 2000. Do the online records go back further than 2000, or how far back? Meaning, I think the Map BC and the Atlas.
Yes, the online records go all the way back to 1961.
Oh, okay.
That's when the province thought they would start licensing groundwater use and developed a groundwater section to start collecting records to get knowledge of aquifers in the area. The old well records, if you look at a well tag number that's very low, like 400, 2000, those are records of really, really old wells. And if you click on them, you'll find the scanned record will be a brown manila record filled in by staff. So throughout the last half a century, the government has produced different kinds of well records in different formats. And you will also find in there well records submitted by drillers using their own format, right? So there's a whole variety of them. I think the drillers are using the standard format because now there are legal requirements for particular reporting of stick up and so on. And so that well record that you see has all of the uh, works requirements that need to be reported on. But yeah, find a well tag number that's pretty small, like 2068, 4043, and you'll find a lot of them. And there are wells that government used to do surveys on that are dug wells. Dug wells are not drilled by drillers. Legally, they're supposed to submit a well record, but I don't think the excavating industry are as in tune with the groundwater protection rig as the driller. So they don't typically find a lot of dug wells records being submitted. But in the old days, when the government did surveys, there were records of dug wells. You could still measure your dug well depth, diameter, stick up, and water level, and send that into government to get your dug well registered. There's nothing preventing you from doing that as well.
But you would think that community supply wells are probably well recorded. They probably have better records than a private well would. Would you assume that?
They do, and yeah, they do. And now with licensing, if they apply for a license, they do have to send information about their well, whether it's a dug well or a sand point, and the government will capture that information and you're supposed to put it into the GWells database.
Okay. Okay. So maybe we're going on to 1247. So I'll make this a last question, Mike. So Bob asks, plumbing codes have standards to protect public potable water system from contamination. Do these standards also apply to private system like wells? So, I mean, when we're talking about public water systems that we rely on groundwater as a source, we're dealing with two legislations, right? Legislation that protects the well, which is the groundwater protection regulation, and the water quality that comes from the well is Ministry of Health. So we're dealing with ministries. So can you say anything further on that, Mike?
Yeah, so the plumbing code probably would not allow you to use sewer grade pipes to convey your potable water, right? The standards in terms of plumbing is I don't know if it reaches into the well. Because when I was working with government and we were developing the groundwater protection rig, I did ask drillers, pump installers, and drinking water officers. So if we were to require a access tube into the well for measuring water level with a probe, does that access tube have to be potable grade or not potable grade? I don't think I got a consistent answer even from my drinking water colleagues. In the end, we decided not to require that. But I mean, typically, I think if you were putting in liners and things like that, they should be potable grade, not sewer grade. Um, yeah.
But and I think that's also a better question for the health engineers
Yeah.
to ask that. So anything that touches a groundwater supply, I mean, touches a drinking water supply, parts or a chemical or whatever it is, it has to meet standards. So
Yeah.
probably a good question for a health engineer. So.
Yeah.
Okay. So thank you so much, Mike. That was incredibly informative and an excellent presentation, and also very relevant and highly desired topic. So many questions from our audience. Um, um, Audience, please be aware that we are now conducting webinar evaluations, and we sincerely welcome your feedback. Your thoughtful and constructive inputs play an important role in helping us enhance the quality of this website and ensures that we continue offering content that is timely, relevant, and responsive to the needs of small water system. So we would really appreciate if you do the evaluation every time. If you have any further questions, please leave them in our website, and we will make sure that they're answered. Your CEU certificates will be emailed to you within a day or two. So make sure you save them and then submit them to EOCP, because we are unable to reissue them at a later date. Our next webinar will be March 24th on Tuesday, and it'll be on unidirectional flushing. So please register, and we look forward to seeing you then. Thank you so much. Thank you so much, Mike.
Thank you, Sukhwinder and Thompson River University and Small Water Systems.
Yes, yes.
Bye-bye.
Thank you. Bye bye.
Thank you. Bye-bye.